Okay, we're going to complete our tutorials for rational functions, chapter 9, by looking at adding and subtracting rational expressions. And we're just going to do one example here, but we're going to spend quite a bit of time looking at the understanding of why we do it. Okay, so let's jump right here to adding and subtracting rational expressions. And this is section 9.5 in your text. We're going to start by looking at a problem in simple arithmetic and look at what we do, because what we're going to do is we're going to follow the same rules with algebra, but we're going to toss variables in. So I've given you a problem where we have 5/9 minus 1/6, and I want you to ask yourself, what's the first thing you look for? First thing you look for is a common denominator. Okay, you might see right away that that's 18, but what we're looking for is the smallest or least common denominator, which would be 18. Okay, so if we take a look at what we need to do here, what you would do is say, okay, 18, I'm going to put it on the bottom. Hold on, I want to back up just a little bit. We're not quite ready to get there. We want to be very explicit about what we do here, even though we know how to do it. So I'm going to write 5/9 right here. Okay, and I'm going to ask myself, what do I need to do to get 9 to 18? So what we do is we multiply top and bottom by 2 so that we get our 18. But remember that 2 divided by 2 is simply just 1. So we're not changing the value of this fraction. And then we'll take our original function, fraction 1/6, and we'll multiply it by 3/3. Okay? What that's going to give us on the left is multiply across 10/18, and on the right 3/18. Okay? And when we do, the last thing that we'll do is our subtraction 10 minus 3. Okay? Actually, we'll just go ahead and combine this into one fraction. We're going to do 10 minus 3/18. This just remembers that adding and subtracting carry the denominator and do the operation between the terms in the numerator, and we end with an answer of 7/18. Okay, so let's review some of the things that we did here. First, we're looking for factors in the denominator. We haven't really done that over here, but we saw 18. We saw 18 as our least common denominator. But how do we get that? Where does that come from? Okay. Another way to look at that is that factors of 9 are 3 and 3 and 6. 6's factors are 2 and 3. So if you notice that if I take and just look at, I need both 3's here, but I don't need to repeat the other 3. 18 is actually the product of only the ones that are necessary. 3 times 3 is 9, times 2 is 18. I could use 54, which is the product of all of these, but that 3 would just have to get factored out later. So there's 2 3's here, 3 times 3. Okay, so we have to have both of them there, but since the 3's already included in the 9, we don't have to have the 3 from the 6, just the 2, because the 2 is unique there. So that gives us the 18. The reason I do that is because the factoring that's here is exactly what we're going to do on the other side. So we're going to try to repeat the exact same steps. I want to make sure I have enough room here. So let's find all factors of the denominator. So the first thing we're going to do is factor the denominators, and that'll help us find a common denominator and the least common denominator at that. So let's pull a 3 out of that. Do you see we can pull a 3 out there? There we go. And we're going to subtract from that 3/2x squared. Notice that 2 times x are the factors there. And so pretty much that's done already. Okay? So let's determine the least common denominator. So in this problem now, you can see, just treat the numbers separately. Okay? So what we're going to need to do is we are going to need to have, I'm going to write in a different color so we can see this separately, and then we'll get back to our problem. In our denominator, we are going to need to have the least common denominator, or LCD, between 3 and 2, which is 6. We're going to need to get to 6. Okay? There's this factor, x minus 3, It's not over here, so we need that too. Okay? This is analogous to the 2 over here. The 2 is out here by itself, but we needed to include it. So x minus 3 is there. So we've dealt with the 3, the 2, and the x minus 3. And then there's this x squared term. It is also a unique factor, so we need to include it in there. Okay? All right. So this is what we need to get to. Now we're going to do the similar math that we did here, where we multiply each term by a particular factor to get the least common denominator. So notice that we had to look at how do we get from 9 to 18, we multiply by 2. How do we get from 6 to 18, we multiply top and bottom by 3. So we're going to do that carefully in this problem now. So I'm going to write down what was given in the first term, 2x over 3 times x minus 3. Now what do I need to multiply this by to get to this denominator? So let's start on the bottom, and then we'll multiply by the top too. So to get from 3 to 6, I need to multiply by 2. Notice the x minus 3 is already in there, but what else is lacking here is an x squared. So really what we're going to do is we're going to take this first term, and we're going to multiply the whole thing by 2x squared over 2x squared. Okay? Because just like the 2 over 2, 2x squared over 2x squared is 1. We haven't changed the value of this, we're just kind of blowing it up. So let's write the 3 over 2x squared here and ask ourselves some of the similar questions. Okay? We're going to multiply that by, what are we going to have to do this time? To get from 2 to 6, we need to multiply by 3. And this denominator does not have the x minus 3 term. So that one needs to be in here. So we're almost multiplying this right side by the unique pieces that came from the left. Okay? And it already has an x squared. So you can see when I multiply this through, I'm going to get 6x squared. So let's make sure that we multiply top and bottom by 3 times x minus 3. Why did we do this? Look over here. To get 1/6 to a denominator of 18, we had to multiply top and bottom by 3. So here we're going to multiply top and bottom by a unique factor that gets our denominator where it needs to be. Okay, let's multiply each term. So let's focus on this left here first and do tops and bottoms. So we're going to get 4x cubed on the top. I'm just multiplying across. And on the bottom, we're going to get what we want. And let's rewrite this as 6x squared, put that term in the front, times x minus 3. All I did was multiply the terms in the denominator. So let's subtract this from a quotient up here. 9 times x minus 3. Okay? And the denominator, funny that, if you multiply this out, 6x squared times x minus 3. So now that we have our common denominator, we can add or subtract, okay? And the denominator will stay the same. 6x squared times x minus 3. But in the numerator, we're going to go ahead and subtract these terms. There you have it, okay? And I need to extend my page just a hair here so we can finish it off, okay? So now what we need to do is simplify, okay? That means that we're just going to simplify the numerator a little bit. We're going to leave the denominator as it is. So I'm going to distribute this 9 through, and what I'll get is 4x cubed minus 9x plus 27. Check for that double negative. And that's divided by, leave your denominator as it is. Okay? And presto. Not as neat as our 7/18 on the other side. Okay? I'm going to undo that because I can do better than that. Okay? But if you review what we've just done, we're following the exact same steps. In both cases, we look for a common denominator, okay? And it's a product of appropriate factors. That helps us determine the LCD. The next thing we do is we write each of the initial terms, but multiply by a particular factor to help us get the LCD. After we've multiplied, we add or subtract, carry the denominator, and simplify. So take a careful look at this math, and what I want you to focus on, and the hardest parts to get, are these two terms right here. Okay? Figuring it out, what each of the initial items is missing to get you to a common denominator. Look carefully at what we did on the left. The math is the same. Look at it again. The math is the same. Somehow we lost an x minus 3 down here. Sorry. Okay, so take a look at this again and review the math and try to work through it again if you need help, or watch the